Afternoon, sir.
Hey students, how are you today? And good?
Hello, sir.
How are you?
Um, Feeling a bit under the weather, but
What now? What happened? You have the sniffles?
I've been happening for a while. The rain just
Oh
exacerbated it.
yes, yes.
I
You have to.
was I was actually considering not coming in because um I I kind of bowel issues and and I don't want it to be a case where say, I'm in the middle of a lesson and then I suddenly have to constantly be going to the bathroom.
No man, psychiatry. You carry the computer. Is a desktop you using or a laptop?
Mm. Yes, sir.
Yeah, man. Just make sure you mute, and you're good to go. You're good to go, my brother. But just be careful, though, please. COVID is still going around. Um, I went somewhere not too long ago,
Mm.
and let me just see how many people out here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm the fourth,
I'm
I'm the 14th person in this grouping,
mm,
and nobody has a mask on away from me. I mean, I came back into the car
mm.
and I put on so this is why I don't have a mask on, but it is COVID is still around and people don't recognize that and they're getting themselves in trouble.
Uh, Apart from that, sir, um, I've been feeling blue for a good while because I've been job hunting and it's hasn't been as fruitful as I thought it would be.
Oh no.
Because
Um,
the jobs I see that are closest to my level are the call center ones, and you know how they have their
no. You can't go to a call center work. If you go to a call center work, just kiss your degree goodbye because them call center people don't want nobody who is going to school. They want to keep people down. So
sir, sir.
yes, yes.
Is this going on the channel?
Trial. What is trial?
No, the channel, the YouTube channel.
Oh, the recording.
Yeah. No,
Yeah.
because there's something I want to say, but I don't think I want to say it if
Okay,
it's
yeah.
going.
No. Well, let us talk about that afterwards because the conversations here. One of
Because
the
I
things
don't
I
want,
want to.
because I don't want it to be to have like say somebody watching the video and then them realize what I said and then we go decide for check my records.
Yeah, no problem. Fine, that's all right. But separating aside from that though, I I have been wanting to purchase we call it now something that I can use to purge the recordings. So, like conversations like these that we're having now, before I upload the recordings, I wouldn't necessarily um, just send the recording as it is. I will go through it and just purge it, the little talking part of it, I'll take out. So it is that is it's just a lesson that is there, because you understand that in a class setting, you will have conversations, of course, not generally related to what it is that is being taught. And that's what a class is supposed to be. But for the recording purposes, instead of putting everything there, I would just go ahead and do that. So it's still an idea of mine, and even to go back into the channel that I have uploaded the stuff, to purge those, so that it becomes permanent archives. But anyhow, yes, Crossway. So you and I can have a little private conversation. Uh, I have a concern. The concern is how many of you are doing your preparations?
So you mean studying and all that?
Yes, sir.
Truthfully, I am starting like my plan is starting like said 8 o'clock on Saturday because we have what 3 weeks left.
We have something like so.
Sir,
Yes, my love.
I messaged you telling you that I can't access Editor, sir.
Oh, yeah, man. Remember, you sent me that message when I was in another group, remember?
Yes, sir.
And then I remember, but it's just that between then and now, after that class, I went and got ready quick, so I could go to a different location. Um, so I really don't get a chance to go on that yet, but I will definitely um look at that one for you. Not a problem,
Thank you, sir.
man. Um, uh-huh, 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 uh-huh. All right, so Donald says that he's going to be late. All right, and then somebody sent me a message to say that this looks like that person. Okay. Um. Mm-hmm. All right, so I'm going to tell you the same thing I told a class I had this morning, because I'm seeing some of the same messages coming in for this class that came in for my earlier class, and it's not the same students. Um, I'm gonna ask that you be safe. I'm gonna ask you to ensure that if you're not well, that you seek, you know, medical attention. If going through any problems, don't just internalize the problems and decide say not going to come to class because you're having problems. Find somebody and talk with, somebody who you can trust, a teacher, a classmate, a neighbor, a family member, whoever it is. Don't bottle it in. Um, I'm seeing just way too many situations where people are going through struggles and they believe they can go through the struggles by themselves, and it does more harm than good. So if you're going through any little something, just find somebody, talk to them about it, explain yourself. Say, I need to reason. You don't have to get into the nitty gritty of what it is that you're going through. If it is that you need prayer, just say, boy, you're the plan. Pray for me on a particular matter. You don't have to tell them exactly what it is that you're going through. Just tell them, say one prayer. But don't sit down. And if you want help, especially with the calculus one, don't sit down in class and no say no learn, and don't say nothing to nobody. Find somebody in class to say, I'm having this challenge. How can you help me? right? We're going to stick together. We're all going to get through with Calculus 1. Come summer, God's willing. I have the second version of it to play around with. So I'm depending on you to do what it is that you're supposed to be doing. All right? Am I understood?
Yes, sir.
All right.
Okay.
So we would have done the last thing that we're on.
Discontinuity was the last thing we discussed.
Right. And in particular, we looked at the
Discontinuity in regards to f of a.
right. What we did was the piecewise function. We looked at some piecewise function, and I would have sent you a document on continuity, and I would have sent you something where we look at a function that is discontinuous. We looked at a past paper question. Well, I didn't do the past paper question in class, but I gave it a past paper question nonetheless. Then we move into piecewise functions. We did a question on piecewise. We did 2 examples on piecewise. No, we did 1 example on piecewise. And then I did another example and send off to you. And then I think we should, in all fairness, I think we should spend a little bit more time now looking at some more piecewise functions. Question: how are you feeling towards this? What are your feelings towards the piecewise functions?
Sorry?
What are your feelings? How are you liking the topic? Not liking it? What difficulty level are you having?
Something I still need to review.
Something that you still need to review. Okay, fair enough.
Because piecewise
Go ahead.
functions were always the things that I really did not like doing.
Okay. What has it done to you? Why I don't like it?
So some reasons always trip me whenever I try to do them.
So since you're not being tricky, I'm tricky back.
Okay, boss.
Yeah, man. No matter, don't tell it. Say, I am the boss of you. You are not the boss of me. And let it know that straight up.
Good afternoon, sir. Good afternoon.
She's trying to hook you up with some older guys.
Sir, can you hear me?
Miss Nicole.
Yes, sir. Good afternoon.
Yeah, I'm gonna ask you to turn on the TV, please.
Hold on, sorry. Yes, sir. I just joined the class. Since the fast track class started. Have you added anyone to EducaSoft as yet?
Long time.
Can you add me to it?
Sure.
I went on Aaron to try to add the class, but I'm not seeing it on Aaron.
Okay, no problem.
However, I want to ask a question to the class. Is there a group for calculus? No respond?
There sure is. You not hearing me?
Yes, sir.
Yeah, man. There is a group. I'm gonna put something in the
Chat?
in the chat now
Mm-hmm.
that you can join via link.
Okay, I appreciate that much.
All right, so it's there, so you can try joining via the link. And then now when you're in that, you can send me a private message with your email address so I can get you onto Edico. Or you can send me a direct message. Yeah, send me a direct message in WhatsApp. All right, good to have you, Nikki.
Okay, thank you.
No problem. Boot of buff. All right, are you seeing my screen, guys?
Yes, sir.
All right, good. All right, so all right. I'm wondering what I should do with All right, let me. All right, I'm going to be writing. All right, I'm going to be generating some questions. I'm going to understand. See, let me write. Hold on now. Hold on, so. Oh. All right. So we're looking at piecewise functions. Given f of x is equals to, bear on with me. I'm making up one as I go now. All right. So you have a piecewise function question. I want you to determine if f of x is continuous at x equals 0 and at x equals 3. X equals 0 and at x equals 3. Start from it, please. Yes, I am. Boy, this Saturday afternoon business now work out, As me start class, me feel hungry.
Afternoon, sir. Sir? Mr. Sean, you hearing me?
Probably move away from his computer.
Oh, okay. Anybody seeing his screen?
Oh, come here when you for me alone. I don't see it neither.
Yeah, see.
That's what I want to tell him.
You're not seeing it? I'm able
No.
to.
You just keep saying Martian has started screen sharing.
I'm going to
Exactly
take a
what I'm
picture of
saying.
what
I'm
she's.
seeing the screen.
I'm going to address the problem to Mr. Sean. when it comes back.
Well, I'm going to send a question in the WhatsApp group.
All right, thank you. Sir?
Hey man.
Yeah, afternoon, sir. I'm not seeing your screen, so I can't write the question.
So you were seeing the screen all along?
Right.
Seven, six, six.
All right.
Are you seeing it now?
Recording in progress. Recording in progress. Recording in progress. Recording in progress. Recording in progress.
No, sir.
I had the same problem this morning. It is saying that I am sharing, but oh man, how did I do it this morning? Okay. What I did was to leave the meeting and return. So oh come on. I don't understand. Did I delete it then? Oh, Father, friend, help me, I pray.
So you asked a question a while ago?
Is anybody at all seeing my screen?
Yes, I'm seeing the screen. Some of us are, I think, but not everyone.
I don't know what is happening now. All right, let me stop share. Oh man. Are you seeing it now? Hello?
Sir, I was always seeing it.
Okay.
Sir, I'm seeing
Thank
it.
you.
Yeah, I'm seeing it. It's not visible.
All right, good. All right, start working now for me, please. Is anybody finished with the question yet?
Yes, sir.
Is anyone
Yes,
finished
sir.
with the question?
I'll send you my answer in the chat.
They didn't hear me.
What is it, sir?
I'm asking, are you finished with the question?
Yes, sir.
Yes, I am, sir.
Is there anyone else working on the question?
I did the answer for 0, so I'm just trying to find 5 now.
All right, I'll give you 2 more minutes, please.
Mm.
I'll send you my answer in the chat.
5 or 3. Sir?
I saw 3 now.
No?
Sir, I haven't attempted the question because I don't know what to do.
That's fine. Leave it alone. Just when I start working with the others, we will see what is happening. That's all right.
Okay.
All right. Let's go. All right, Nikki. Asking you to pay some special attention here, and I'm going to encourage you to learn it and absorb it quickly. We just started this last.
Sir, your microphone is mute.
So you know, so me talk to myself, right?
That's right.
So I was actually talking to you to say that who do you know in the class? Maybe you could ask them to just go into the group and just forward you the previous handouts that I would have sent. Maybe about 2. I think this is the 3rd class we're having. So I think I would have sent about 2 sets of handouts. Or if not, somebody could just circulate it, recirculate it in a group. Have you joined already? Have you joined the group already, Nikki? Are you guys hearing me?
Hold on, clear, sir.
Yes, sir.
Yes. Yeah, so I'm asking you to join the group.
Yeah, man, I joined the group. You sent the link.
Right, good. So if somebody could just repost it so at least you could get the stuff. All right, let's go. Let's go. Remember now, from this week, I've been having, I'm not so confident with my devices. Thursday, Wednesday, I had a rough time in calculus 2. Eventually, the computer pretty much died, one of them. And so I'm trying to sort it out. And then this morning I was having some other challenges. So I'm not so confident. So when I ask if you're hearing me, please just respond. Okay. So the question says, given f of x is equal to all of that, determine if f of x is continuous at x equals 0. All right. So we need to determine what is happening at x equals 0. So what I'm going to do is to find the limit as x tends to 0 to the left. Remember, this means to the left. To the left of 0. All right. So I'm finding the limit. I'm finding the limit as x tends to 0 to the left. That negative superscript sign is saying to the left. Now, when you look at the function, this function deals with when it is what? When x is what?
Yes, sir.
This function x squared over 4x minus 1 is when x is what?
When x is shit, what's the term?
No, man. Just look at the thing. When x is
Greater than or equal to 3.
When x is 3.
Yeah.
So I'm not, it's because I'm looking at x equals 0. This function is not a part of what it is that I want to do because this one corresponds to 3. To the left of 0, I'm seeing 0 here, so I know I have to use this one. And I'm seeing 0 and 3 right here, so I know I have to use this one in any event. This one can be used twice because it have the 0 right there, so it have the 3 right there, so.
3, yes.
So I'm going to use this one so, and I'm going to use this one so. All right, so this one is going to be used for 0 alone. This one is going to be used for 3 alone, but this one is going to be used for both 0 and 3. So we know, so we're ruling out this one for the 0 because it only corresponds to when x is greater than or equal to 3. So of these two, of this one or this one, which one of them talks about when x is to the left of 0?
5x plus 1 would be the first one.
Why?
Because in regards to the expression, it states x is greater than or equal to 0. So that would be the first one I would start with.
That's not the reason, Crosswell. That's not the reason, please. Why is it that you're saying 5x minus 1 is to the left of 0? I did this with you last class. I sent off the notes to you. Why is it to the left? Look at the notes and table, because I'm not going to tell you today. Look at the notes. I gave you a summary. I gave you a whole summary that I did up for you guys. Look at it.
So basically,
less than.
Because it is?
Less than.
Because it is less than. Thank you very much.
Sorry, I never heard.
Did anybody hear her?
No.
No, man. Sir, every time I say something, you never hear. Don't know.
No, but that's why I asked the class, because that part is true. I've never heard you. So that's why I asked the class for the class to tell me, say, yes, sir. Should they say so? I did not hear you. Did anybody hear Joe say that to the left?
Sir,
No,
is the
sir,
one
just now.
saying
Just
so.
now.
Just no. I saw she say,
Sir,
man. Me
sir,
say,
so
and it's so close on the fish. I tell people the big life on the eve of Christmas, Christmas, eve of Sunday. And I never hear you, Joe. You must speak up next time. Speak up louder next time. All
okay,
right.
sir.
So it is to the left. Less than, I keep saying less than is to the left. L for L. Less than and left. So less than and left. So because we are looking at the limit as x tends to 0 to the left, we need to look at the piecewise function that is less than. And the one that is less than, it says x is less than or equal to 0. X is less than or equal to 0. Now the function that is less than is going to be 5x plus 1. 5x plus 1. So that's the function that we're using, not because it's the first one. Not because it's the first one. It is because it's to the left. To the right is going to be greater than. The right is going to be greater than. The left is going to be less than. Fair enough?
Yes,
Yes,
sir.
sir.
All right. So to the left of 0 is going to be 5x plus 1. Now what this means is that anywhere in the function I see x, I'm going to put 0. So 5 times 0 is 0, and 0 plus 1 is going to be equal to the 1. So the limit of that function tends to 1 from the left. But remember, we need to investigate not just the left. In order for this function to be of a good behavior, we have to investigate what is happening to the left and to the right of the function. We have to investigate what is happening to the left and to the right of the function. We can't just look at one. We have to look at both, to the left and the right of the function. Fair enough? Somebody talk to me, no man.
Oh, wait, you never did hear
Yes,
me.
sir.
No, I didn't at all. I don't know what is happening, but I didn't hear you. All right. I'm looking to the right of 0 now. I'm looking to the right of 0.
Your screen gone blank, sir, again.
My screen gone blank? Whoa.
Yeah.
So, sir, are you going to use the 0 to
So
the 0
it's
to lesser than or equal to?
Right. Yes, yes, Nick. Very good. Question though. Anybody else seen the screen?
Yes, sir.
I don't know what is happening. On our computer students, what is happening? Seriously, something happened. What is happening?
So I guess it's based on the bandwidth. For my bandwidth be low, I couldn't see it.
But
Sir, I'm not seeing the screen currently.
Sir, I'm seeing a screen.
guess what? I'm the only one that is connected to this internet, you know. So
Sir, I doubt it's on your side, but
Probably they have to
on
probably
my-
they'll have to try to restart their computer.
No, that's not the point. Every time when I come off of Zoom, you see, it just says Mark Shan has shared screen. That's the problem. So it's just that I need to stay on the thing. I'm requesting, sir, if you
Yeah,
could just reshare.
Sorry, so not seeing the screen.
Yeah, maybe I have to restart because I'm not seeing the screen. Yes, sir, I'm seeing now. Not hearing you, sir.
Not hearing you, sir.
Oh boy. Actually, see. Let's go again. Hear me now?
Clearly.
All right, thanks. You guys have to really keep close and stay close by so that you can again conquer this one.
One you again in case somebody something.
Hmm?
Oh no, may think it here, my sister.
Okay. All right, so let's go. So what I was saying to myself a while ago is there's only one function like the first one that these in this case as x tends to 0 to the right. To the right. See, we read it this way. We read this one inside out as your handout says. When we have the double inequality, we read it inside out. So this one is saying x is greater than or equals to 0, but x is less than 3. X is greater than or equals to 0. So greater than means that it's going to the right. So this is a function that goes to the right. So to the right of 0, I'm going to have x squared plus 2x plus 1. Anywhere in the function I see x, I put 0. So that's 0 squared plus 2 times 0 plus 1. 0 plus 0 plus 1 is equals to 1. So therefore, seeing that we move from the left and from the right, and that both of them are tending to the same limit, we say that since the limit x tends to 0 to the left of f of x is equals to the limit x tends to the 0 to the right of f of x, comma, then f of x is continuous at x equals 0. Since the limit of the function from the left and the right equal the same value, then we say that the limit of the function exists and it is continuous. It is continuous. Any questions so far? Nikki, you see that?
Yes, sir. I see what you're doing. I'm trying to wonder if I'm trying to see if I understand exactly what you did.
Okay.
All right, I should bring this up now. Well, it wouldn't be, it's not important, but basically, but in this case, say they wanted us to write the values. We would just write them as, in this case, just, for the first limit, it would be equal to -1, and for limit 2 would be equal to +1, basically. Right. And just simply say that that it to prove to say that it's continuous. Can you confirm that for me, sir?
It would not be continuous, Crosswell. If one is -1 and one is +1, it couldn't be continuous. That's discontinuous.
No, that's what I mean. I mean, like, when you have both values, because it mentioned in this case, when you're referring to, like, say, the left.
You're gone.
Sir, please clarify for me. All those things, are they X or just strange sign?
There are X's there. They're my sexy X's.
So then X the what? I
Don't
Nikki, leave me alone.
don't bother. Sorry, I just read the paper. I see the problem now.
There are X's, Nikki. Okay, Crosswell, I'm happy. Yeah, man. That's why I sent you the stuff, you know. So when I send you the work before, I want you to just go through the stuff so that when we meet, if there's something that you're not understanding, then I can easily go through those with you.
Yeah, just check paper. I just checked paper. My mistake was that I misread one of the explanations.
Okay. And incidentally, what you're seeing there, I don't think you'll find in a textbook, because I sat down and I wrote it based on how it makes the understanding comes clearly. So if you go through that, just try and understand what it is that I'm saying. I use the very first example I did in class is where I took the information from. So if you're reading through the summary and you get stuck at any point in time, just go back and look at the question to see what I would have done. Really not difficult. I'm saying this to you. I'm gonna get to some difficult areas and I would say to you, I understand if you don't get it because it is difficult. But the one here, it's not difficult. May I tell you the honest truth. So just try and appreciate it. It's not hard. So I am investigating technically what is happening to the left and to the right of my function. When I investigate what is happening to the left and to the right of the function, if under investigation, all right, put it this way. You're investigating a matter. There were two witnesses. The accused is saying that I did not do it. But the accuser is saying you did it. There is a witness on either side of the fence. One witness for the accuser, the other witness for the accused. And if somebody independent is looking at the matter and say to me, you're under oath, give me your exact recollection of what happened. And you are going to tell the person, well, ropes, and then somebody else comes and gives the exact explanation and said, this is what happened. Your only conclusion is one of the two, the accuser or the accuser's line, and you can say, based on investigations, this is what was revealed. That's exactly what it is that I'm doing. You asked me to find the limit of the function as it tends to 0. I have to look on the left of the function of 0. And I have to look at the right of the function of 0. I'm looking at both left and right. And when I look at both left and right, if both of them come out to be the same value, it means that the function is continuous. If when I look to the left, I get one answer. When I look to the right, I get a different answer. I can say that the function is discontinuous because my responses were different in both cases. When they are the same, I say that they are, the value there will be continuous. Does that make sense?
It does.
All right, watch me now. Watch me. I'm looking at the function. Okay, so look here now. Now I've done x equals 0. I'm going to look at x equals 3. I'm looking at now x equals 3. Can I use this function any at all?
No.
Why?
The term. I was gonna say
X equal to 0.
Yeah.
Because it corresponds to 0. So
I was gonna say it's not. It isn't related to 3.
So this one fully related to 3, but the one you share it. Hold on there now, you know. Remember, we read inside out. So this one is read x is less than 3. Which are the functions then?
Hold on. Question. When I say it's related to 3, what makes you say it after working it out, they get the answer is going to be equal to the same?
No, when I say related to 3, this function is not tending to 3. This function is when x is less than 0. So this function here is being investigated in relation to 0. This function is being investigated in relation to 3. This function is what is tying this function and this function together, because this function is being related to both 0 and 3. Does that answer your question?
Not really.
When I'm looking at the functions that I'm interested in, Nikki, when I say that I'm now investigating at the point x equals 3, at the point x equals 3, I cannot use 5x plus 1. Why, sir? Because that is where that function is corresponding to when x is relating to 0. The function relating to 3 is this: x squared over 4x plus 1 is when x is greater than or equals to 3. And in this case is when it is less than 3. So this function here corresponds to both 0 and 3. See it here, 0 and 3. This function is only relating to when it is 0. And this function is only relating when it is 3. Put it this way. That one here, or when a baby here, about mother and father. See it here, so? Pick me. with both parents. Here is and this is mother and this is father. The one first a mother and the one your father. So this one here is born in wedlock. The one here is unrelated to the mother. But sir, if mother and father married now, yes, mother and father married. But this child, would this child have any DNA for the father?
No.
No.
No, you.
Would this child have any DNA for the mother? Said no, no.
No.
Good. The one year, would it have DNA for the mother?
Yes.
And for the father too?
Yeah.
Yes. Because this one is linking both x equals 0 and x equals 3. This one is only linking x equals 0. It has nothing to do with x equals 3. This one has nothing to do with x equals 0. It only has to do with x equals 3. So this nice blended family of f of x. Mother, father, pitney, boom. This is mother and our first pitney outside of marriage. This is father and his pitney outside of the marriage. And the 1 year now is when all of them come together. But guess what? All of these are related, you know. Sir, how you know, Sita? F of x. They're all related f of x. Oh, that means this one did a deed poll and take the father name if you want to say so. And this one would have already have the father name. So this one would have feel like an outfit of the family and say, you know, I want to get his name. Yeah, man, all of them are related, but there are conditions to the relation. Am I clearer now?
Yes, sir.
Nikki.
Sir, what I'm understanding here is, get you said all of the x square plus x 2x plus 1. What I'm understanding is that all of the both 5x plus 1 and x squared over 4x minus 1 have in the middle x squared plus 2x plus 1 piece of those function is inside of that. That's what I'm getting.
Okay. And what I'm saying to you, Nikki, is when I'm investigating x equals 0, watch me.
Because I feel that information.
Watch me. You see me can draw this line right here, so?
Yes, I'm seeing it. Yes, sir.
All right. Everybody can see this?
Yes, sir.
Yes, sir.
All right. The mere fact that I can draw the line, so them two are related to x equals 0. I'm going to draw the line, so them two are related to x equals 3. You notice, no 5x plus 1, no connect. You notice when I'm drawing my line right here, so I'm not touching this none at all. This condition here is only talking about these two. When I do this, you notice this don't get touched at all. It's just these two. You follow me?
Yes, I'm following.
All right. So we now need to investigate x equals 3. So to the left of x equals 3, this is x less than 3. So to the left of x equals 3 is going to be x squared plus 2x plus 1. X squared plus 2x plus 1. So what I'm going to have is 3 squared plus 2.
Sorry. Let me just ask. Anyone else in the class understand what sir just was saying?
You.
Okay, are you able to explain it? Probably what sir is in it. It's not connecting. One last chance, sir. Please go back to the page.
All right. So what I'm going to do, I'm going to press pause and I'm going to have somebody go ahead and do that for me. I'm
Thank
pressing
you.
pause and somebody will do that for me. All right? I have no problem with it.
All right. The young lady that said yes, are you able to explain for me, please, so if I can better understand?
So it's like explain the whole thing.
No,
So
what you understand when you were saying why it's investigating and why it's related or so. The formulas he was trying to help me to understand and why they don't and why they do.
I don't think I know how to explain it like that to me.
Are you able to explain to me how you understand it?
How
Are
I
you-
understand it, for the first part where it says x equals 0, what I do is find the equation that has 0, like the first one has 0 and it's going to the left, and the second one has 0 and it's going to the right. And for x equal 3, I find the equations that has 3, the one on the right hand side that has 3, anyone that has 3, I use that one. Like the middle one, it has both 0 and 3, so you can use in both equations. But the top one where it has 5x plus 1, that only has 0, so it can't go in the second equation where it says x equals 3. And the last one, x squared over 4x minus 1, it only has 3, so x equals 0 cannot be used in that one. If you understand.
Okay, yeah, I think I understand.
Yeah.
It's much clearer. Thank you.
All right. So do me a favor now. Can somebody else try to explain to Nikki? Thanks, Joe. Appreciate it. And you're on point, Joe. So I know that you're understanding this topic.
Thank you, Joe.
I need
Yeah,
somebody else in the class now to take another turn in explaining to Nikki for me. And let me just pause here and say something to you. It's one of the things that team teaching is always very important. This is what I normally do from a long time. And what it does for me is to help me to understand even more what it is that I'm doing, right? So when you help somebody, you are concretizing the information in headspace. So don't think that you're going to give out the information and you're not going to be left with any. So I'm going to ask somebody else now, because it don't make sense to move on and then we don't fully understand. It gives me an opportunity to ensure that you understand what is happening. So do me a favor. Thanks again, Joe. I need another take for anybody. I'm not going to call upon anybody who believes they can explain to the class how it is that they understand it. Let us see if we can get an understanding from it. All right? On the mark, get set, go.
Your phone is blood in your mouth.
All right, let me try. Okay, so if I can see to the left of your screen, the limit of x as it approaches 0, and you see the minus sign as a superscript on top of the 0 right there.
Yeah, I see it.
Yeah, just take that minus sign as left, right? Just take it to mean that that x is going towards 0 from the left side. So what I always do, I always picture a number line, and I see the y-axis and I see the x-axis, and I see the number 0 in the middle. And what I see is I see x on the graph go just moving towards 0. If you get what I mean, right? Okay, so and then I see, so you understand that, right?
Yeah, that's I understand.
Okay, so I'm visualizing it now, and I'm seeing here the condition x less than or equal to 0, and that just means the same thing. X approaches 0 with the minus sign, You seeing that?
Yeah.
Okay, so that's the same thing. And because that is in the same row, so to speak, as the 5x, as the 5x plus 1, that's in the same row as x less than or equal to 0. You're seeing that?
Yeah.
So that basically means that 5x plus 1 is saying that x is approaching 0, or that whole equation is approaching 0 from the left side. You're getting that?
All right.
Okay, so if you look to the other, if you look to the other 0 now, so we substitute, all right, we deal with the equation by substituting x by 0. So 0 multiplied by 0 plus 1 would give us the 1. All right.
Yeah.
If you work that out, yeah. And so x squared, if you look at the next row now, x squared plus 2x plus 1, right? And you say the next to it, you say 0 less than or equal to x, or as Sir said, x greater than or equal to 0. If you read it from inward to outward, you seeing that? Okay, so that basically means x greater than or equal to 0. That basically means, as you can see to the right of your screen, the limit of x approaching to 0. And you're seeing the plus sign right there on top of the 0? That means that x is approaching 0 from the right side. All right? So it's approaching 0 from the right side. So that means that because it's in the same row, because x squared plus 2x plus 1 is within the same row as x is approaching 0 from the right side. You seeing that?
Yeah.
That means that function is approaching 0 at the right side. Okay, so you just substitute 0 wherever x is, and you get 1. You work out that, and you get that answer, right? Well, say that's the answer, all right? So you would get 1, okay? So because you have 1 for this equation as the answer, when you substitute 0, because it's to the right side of the 0, right? And because I get 1 for 5x plus 1, right? You would say, because I get the same answer, you would say it's continuous when x is equal to 0. Yeah, you understand that? Or you don't?
All right, so far until you reach its continuous when x is equal to 0.
Okay. Well, as long as you get that, all right. So basically, the reason why I said that is because when you work out 5x equals 1, and when you substitute x with 0, you get the 1. And when you substitute 0 into x squared plus 2x plus 1, and you get the 1, because you're replacing 0 with the x, you know. You understand that?
Yeah.
Right. So when you multiply it now, when you apply it to the equation and you get 1, right? You're basically saying that both answers are the same. So that means when x is equal to 1, f of x is continuous.
Right, but before you do that though, the functions are of a good behavior because it is behaving good from the left-hand side. It is also behaving good from the right-hand side. So because you investigate it from the left and the right and it is tending to the same number, it means that the function is continuous. If coming from the left and coming from the right, both values are different, then the function will be discontinuous at that point. So there's continuity when you look at the left-hand side and the right-hand side. Because remember, you know, as he says, when he looks at the number line and he's at 0 and coming from the left to 0 to the number line, he's looking at the behavior of the function coming from, going from that left-hand side. He's also looking at the function coming from the right-hand side. Now, when he looks at the function for those two sides and the function is giving the same answer, it means that the function is behaving well and the function is continuous. Otherwise, you said that the function is discontinuous.
Okay.
Very good. Continue.
Thank you.
Yes, sir. So that's it.
All right. But okay, so I hear you say, Nikki, thank you. So what you now need to do is you now need to take turn, Nikki, to explain the question to the class so that we know that you understand what is happening. And while you explain to the class, I am not going to come in to say you're right or you're wrong. I'm listening for the classmates to tell you where you went wrong if you go wrong. All right? So it's now your turn to explain.
Okay. So what I understand based on both explanation is that, all right. So the question is asking for us to investigate x equals 0 and x equals 3. All right. And being that the x equals greater than or equal, less than or equal to 0 means that we're going to go on the number line. Using the number line, less than 0 is 0 point negative, is a negative value. So we're using the 5x plus 1 because it's as a 0 in it. So using it, we're substituting the x for the 0, which is algebra, which gives us the 1 equal to 1 after substitution. Now, so moving on, we're investigating the x equals 3. We're using this value, the 0, the equation in the middle, x squared plus 2x plus 1. Why are we using this one? Because it have 3 in it and 0. All we're going to know is where on the number line we're going, with the left side or the right side, approaching the left or approaching the right. The equation here is asking x is greater than or equal to 0. So greater than 0 is on the right side on the number line, where it's whole numbers, not negative numbers. So with doing that, you substitute again the 0, the x for the 0, which gives us to 1 as the answer. And as Sir said, because on the left and the right side, both numbers are corresponding, the same. So we say it is continuous. So if we work it out and one side, the left side or the right side, they're not the same, we will say it's discontinuous. It's not behaving itself. That's what I understand so far.
Is she correct, guys?
Yes, sir.
Yes, sir.
So you're talking to yourself again.
No, man, I'm just trying to unmute. Hold on. All right. Now, it's very important, very, very important that we try to understand. And I don't want anybody to feel, say, I'm putting you on the spot. You'll be very surprised to know how much it helps you to assist somebody by just explaining. All right. So it's very, very, very important. All right. So with that said, I should be allowed now to move on to the function when investigating what is happening to the right. So let's go back here now. So to the right, so not to the right. I'm looking at the left actually. You remember the negative sign is to the left, right? Anytime we say negative here, it means that we're looking at the left. Positive is to the right. So I'm looking to the left of the function. The left of the function is saying to me, x squared plus 2x plus 1 is corresponding to the left of the function. X squared plus 2x plus 1 is corresponding to the left of the function. So what it is that I'm doing, I'm looking to see what happens at that function at the point where x equals 3. Anywhere in the function I see x, I'm putting 3. So 3 squares will be 9, plus 2 times 3 is 6, plus 1. And that looks to me like it works out to be 16. So the function to the left is saying to me that it is 16. Function to the left is saying to me that it is 16. Let us look at the function to the right.
Sir,
So function, go ahead.
sir, is it that if we have a decimal, we'll leave it as a decimal or we'll change it? If it can change to a whole number.
Why you want to change it to a decimal? You're given a fraction, just leave it as a fraction, mommy.
Sir, I never get a fraction. Sir, I got a decimal when I did it.
Press the F to D or your shift
Oh yeah, sir. Sir,
ABC button to convert it.
yeah.
So the limit as x tends to 3 now to the right. To the right is going to be the function x squared over 4x minus 1. Anywhere in the function I see x, I'm going to put 3. So that is 3 squared over 4 times 3 minus 1. It's going to be equals to 9 over 4 3 is 12 minus 1 is equals to 9 over 11. Are those two values the same?
No, sir.
Is it continuous?
No, sir.
So since the limit as x tends to 3 to the left of f of x is not equal to the limit as x tends to 3 to the right of f of x, comma, then f of x is discontinuous at x equals 3.
I got the same response.
Yeah, man, that's it.
I was confused as to whether or not I was doing it right, so I waited to see how much you would do.
Yeah, man, I say it go.
Well, sir, the statement is required first. We are required to write that statement in exam or after we do the question. Since
Determine if the function is continuous. So you know, it's a question I'm asking. You know, they're asking you to determine whether or not it's. So you have to make the statement. So you do the question alone, and not making the statement to say that it is continuous or discontinuous. You would have not answered the question.
Okay, thanks.
Yeah, man. Sure. Let us see. You know what I was doing. I'm doing another one. I'm doing another one. All right. Sorry. Brain drain a while ago. All right. You have another question now. Start for me, please. You guys are okay? I'm just checking in. Are you okay?
Yes, sir.
Okay, good. How is the? I'm not hearing from you guys. I'm very worried. Are we okay?
Sir, I sent you the answer in the chat a good while
Okay.
now.
All right. So Joe, I was wondering where you sent that stuff. I was wondering if it was WhatsApp, but I just recognized that I'm connected to two devices, so I'm seeing it to the other device. Okay. I won't comment on that one yet. Tara, I see that you. Okay, you're giving me a similar sort of response. All right. Let us see what will
Is
happen.
it possible, sir, to get that answer?
Yeah. Absolutely. Remember, say I test it out, you know, say no. Anything is possible. Yeah, man. Yeah, man. So in essence, you can get both to be continuous. In essence, you can get both to be discontinuous. You can get one to be continuous and the other discontinuous, or you can get one to be discontinuous and the other continuous. It's just a combination of things that you can get. So we're not sure yet. All right, I'm gonna Nikki. You're too silent, you know. You're way too silent. And when you go silent, I know exactly what is happening. How you stay? Nikki. Nikki gone? No, she's here. Nikki, respond for me, please.
Sir?
Yeah, it's like you're gonna put on the chicken foot soup.
I'm at the computer right here, sir.
Okay,
Just
I was
have to
calling
start
you.
it.
All right. All right. So I'm going to do the question. I'm going to do the question, and then I'm going to generate another question. So it is that you can do. Listen to me. This topic is going to be on your mid-semester exam. So will it be on your final exam? It's on your mid-semester. So will it be on your final semester, final exam? What we did last class in terms of finding the limits of a function would be on your mid-semester. So will it be on the final paper? So you have to understand it. All right. I'm going to go through the question now, and then I'm going to give you another question to work for me in the meantime.
Oh, sir,
Yes, please.
I'm going to changing my answer because I realized I missed off something from the last,
No
the
problem.
minus
No problem.
22. All right.
No problem. No problem. You're allowed to change your answer. All right. Let me just write this here for you. So it says given h of x is equals to 2x plus 1 over x minus 1, where x is less than 2, and x squared minus 2, where x is greater than or equals to 2 but less than 5. And the third one says x squared plus 4x minus 22, where x is greater than or equals to 5. Is h of x continuous at x equal 2 and at x equal 5? I do not know. I am here trying to figure out. So I'm looking at the limit as x tends to 2 to the left. Which function deals with x tending to 2 to the left? Huh?
Sir,
Say it again, Joe.
so I was saying the first one.
2x plus 1 over x minus 1. 2x plus 1 over x minus 1. So anywhere in the function I see x, I'm going to substitute 2. 2 times 2 is 4 plus 1 over 2 minus 1. 4 plus 1 is 5 and 2 minus 1 is 1. So that tends to 5. So the function there tends to 5. We also now need to find out what is happening as the limit x tends to 2 to the right. Which function deals with x tending to 2 to the right?
Sir, the second one.
X squared minus 2. Right. X squared minus 2. So anywhere in that function I see x, I'm going to substitute 2. So this now becomes 2 squared minus 2. 2 squares equal 4. 4 minus 2 is going to be equals to 2. Is the function continuous?
No, sir.
No, sir.
So since the limit as x tends to 2 to the left of h of x is not equal to the limit as x tends to 2 to the right of h of x, comma, then h of x is this: continuous at x equals 2. Does that make sense?
Yes, sir.
Now I need to investigate what happens as it tends to 5. So the limit as x tends to 5 to the left corresponds to which function?
Sir, the last one. Oh, sorry, sorry, the second one.
The second one. X squared minus 2. Anywhere in the function see x, I'm substituting 5. So this is now 5 squared minus 2. 5 5 equals 25. 25 minus 2 equals 23, I think. Then we also need to investigate the limit as x tends to 5 to the right. Which function deals with x tending to 5 to the right?
And the last one.
X squared plus 4x minus 22. X squared plus 4x minus 22. Anywhere in that function I see x, I'm substituting 5. 5 squared plus 4 times 5 minus 22. 5 squared is 25. Plus 4 times 5 is 20. Minus 22. What that works out to be again, please?
Sir, the last one, 67.
Really?
Sir, yes, sir.
25 plus
again.
22 minus 22.
Oh, sir, minus. Sir,
Yeah.
you know, at the
Yeah,
back of me have plus 22.
I just want them in the power.
So is it continuous at x equals 5?
Yes, it is,
Yes,
sir.
sir. As I said, I saw where I went wrong there. So I forgot the
Right.
22, the minus 22.
So since the limit as x tends to 5 to the left is equal to the limit as x tends to 5, sorry, of h of x, I need to name the function, erasing, of h of x, and it's equal to the limit as x tends to 5 to the right of h of x, comma, then h of x is continuous at x equal 5. So you have to be very careful because a miscalculation can give you the function being discontinuous when in fact the function is continuous. Fair enough?
Yes, sir.
Are we okay? Crosswell,
Yes, sir.
Tara, well, Tara was fine.
I'm
Yes,
right
sir.
here, sir.
I know Joe is fine. Madden, or you stay. Daniel,
Yes,
how you
sir. I
stay?
got the only thing I didn't do. I got the top one right. I did one of the bottom ones with the right with the
The minus
23
22.
using the x square plus 4x, but I didn't work out the other one as it.
Okay. All right. Dan, how you stay?
I'm good, sir.
All right. Shantia, how you stay? No answer. All right. I'm going to generate one more. Then I'm going to give you about 10 minutes, 10, 15 minutes to work it through. Does anyone have a copy of a past paper with them right now? I mean, on hand? Yes, no? Maybe
Sir, I
so?
don't think.
Okay, sorry. Let me just generate one more. I wanted to. All right, let me just generate one quickly. One more, that is. Uh, determine if g of x is continuous at, I just won't tell you. Let me generate the function first.
Sir?
Yeah.
It's raining where I have, so I'm have to end class and go and pick up my son.
All right, no problem.
I won't end. I will just miss out what you're doing for now, but I'll come back.
Mm-hmm.
Sir, where you have the second one, you can separate it a little bit, please. Thank you.
No problem. This is going to determine for me whether or not I can move on from this topic. I need to because time is of the essence. So determine if g of x is continuous at x equals -1 and x equal and x equals 1. All right, on the mark, get set, go.
Sir, I sent you the answer.
Give me a minute. All right, I'm seeing your answer, Joe. Is anybody else working? You guys saw the reminder that Joe put place into the group. Every now and again, I have to give a little one question on this so that you guys can remember.
I right. I'm doing them right now, and
what, Crosswell?
no.
Listen to me now. No, you stop. Or have a conversation with me and then just end the conversation at the middle at the second time leaves in class. Don't leave the conversation at the middle. All right, continue working. What about the rest of you now? Are you guys finished? The rest of you? I saw an answer for Joe.
I send mine also.
Okay. All right. So make we try this now. Make we try this. The limit of a constant is
The constant itself.
the constant itself. So the limit as x tends to -1 to the left of 14 is going to be equals to 14. The limit of a constant is the constant itself, not change. And then now we're going to find the limit as x tends to -1 to the right. Which function deals with x tending to 1 to the right?
So the second one.
X
All
square
right.
minus 3x plus
Very good. X squared, very good, Tara. X squared minus 3x plus 10. Anywhere in the function I see x, I substitute -1. So that's -1 squared minus 3 times -1 plus 10. -1 squared is 1. -3 times 1 is going to be +3 plus 10 equals 14. Oh, continuous, don't?
Yes.
Yes, sir.
So since the limit as x tends to -1 to the left of g of x is equal, well, hold on a minute, that's soon right, guys.
Sorry.
Yes, Crosswell. To the limit as x tends to -1 to the right of g of x are equal, comma, then the function is continuous at x equal -1. Any questions relating to that?
No, sir.
I'm from you.
Yeah, all right. Yeah, all right, Tarabu.
Yes, sir.
Nice. Daniel,
I got that
Dal.
one. Mhm.
Very nice, Tara. Daniel,
Yes, sir.
we don't understand what is happening. You're not talking to me in class. The last time I heard from you was when you explained something to Nicole.
No, sir, I'm understanding.
No, but we want to know. you're not responding to me. Even when I'm asking the question, you're not unmuting to respond to me. I don't know if you're understanding. You see my point?
Yeah, I'll let you know, sir.
Yeah, man, please. So when I ask the question, just let me know in the event that I have to go through this stuff again. You see what I did for Nicole so she can understand? Yeah, I need to make sure that you understand because I don't have much time, you know. I have some big wigs to go and look at. So I need to get these ones out of the way. A question such as this can carry as many as 10 marks. As many as 10 marks. So a question like this will have 2 parts. One for 10 marks for this and another piece for 10 marks. All right? So then g of x is continuous at x equals -1. All right? Is a function continuous at x equals +1?
Was it? Sorry.
No, sir.
Why not?
Well, for
What
my
is it?
answer,
To the left of +1. To the left of +1, what limit you got?
I've got 12.
What?
Yeah, we get the same thing.
Is it supposed to be 12 though?
You're supposed to, yeah, I think.
And then the bottom one would have been 1/2.
What you got for the bottom one, Daniel?
A half.
And what you got for the to the left of the function when x equals 1?
12.
How did you get 12, Daniel?
All right. So I substituted 1 for x, so that is x squared, which is 1. I substituted 1 with x, 3x, so that's 3, -3 multiplied by 1, so that's -3. Okay, and so I get that's plus 10, so that would be equal to 8.
So why did you tell me 12, Daniel?
So I must be seeing some stuff, but it is 8.
That's one of the challenges that I have, you know. And though my comment is not directly related to you, it's just a general comment. I've asked Mrs. Campbell to speak to the students last semester. When we don't speak up in class, we think that we understand the stuff because, yeah, man, I get what you're saying and I know it. I want to hear you speak. I beg you to talk to me in class because sometimes we make some silly computational errors and cost us marks that it shouldn't really cost us. It really shouldn't cost us.
Nobody wants to put up them hands and get it wrong.
No, but I mean, this is what it is.
Been that way since high school. Been that way since prep and primary school. Nobody wants to dunce. Nobody wants to put up them hand and get the wrong answer.
Well, guess what?
It is.
It is what it is.
You have to go beat it out to them or make them lose their money or something.
At this stage, trust me. I remember, one lecturer shamed me on campus because lecturer teach, and me sure say lecturer teach himself, and me not understand how thing with lecturer do. And I raised my hand to ask a question and turned to me and said, put your hand down. That's why you have a tutorial class. Nobody just go university, don't know the ropes. And the whole interfaculty looked at me and laughed into scorn. I was most embarrassed. And I sat down in class and I said, okay, fine, I don't understand nothing going on because I'm lost from here. There's no way I can follow through. So I had to go and find help in order to get what is happening, students. And another thing about it is not just math. It is not math alone, it is also happening in your other subject areas. And predominantly, the class is an evening group, and you guys are doing computers. So if you're doing your algorithm and your programming and you don't one programming mistake throws off every aspect of your programming, and you come out to the exam and say, yeah man, me ace that, and you recognize that you turn your NAND gate into your AND gate, or your NOR gate into your AND gate, and it's just a simple error that throws you off. Come on, come on, come on, guys. We need to do much better than this. Um, Graduation is coming up, and I saw one of my calculus students being valedictorian at the last graduation. It gives me encouragement to say um, it can happen. And he topped the graduating class at a 3.74 GPA. So it shows that he did pretty well in calculus, or else the calculus would have dropped his percentage. So it can happen. All right. So yes, it's going to be 8, because anywhere in the function x squared minus 3x plus 10, I see x, I'm substituting 1 into the function. 1 squared is 1, and negative 3 times 1 is negative 3 plus 10. 1 minus 3 is negative 2, and negative 2 plus 10 is positive 8. And that's to the left of the function. To the right of the function, it's going to be a half. So since the left-hand side of the limit is not equal to the right-hand side of the limit, then the function is discontinuous at x equals positive 1. I'm not going to give any more question on. I'm not going to generate another question. I think I've generated enough questions. I'm not generating any more questions. I want you to do something for me, each of you. Is there a question coming in for me?
Yes, sir. I don't like that tone, sir. I don't like what I did.
No man, this is not the vexation tone. It's not the vexation tone, this one. This one is, I want to see, I want a past paper question, because I want to give you a question, because this type of a question that I'm going to give you now will tell me for sure that you are understanding. Can somebody, or different ones of you, can you try and generate a past paper for me, please, on the system? I give you a couple of minutes while I do the other slide. I give you a couple of minutes to do that past paper for me, please. X squared minus 3x minus 10 plus 10. X squared minus 3x plus 10. The limit as x tends to 1 to the left. Guys, make sure that you're generating a past paper for me, please. I'm depending on you to generate a past paper or two. Drop it in a WhatsApp group so I can look at it. I'm looking for a particular question, a particular type of question. How is the search going? Anybody finding anything yet, please and thanks?
Still looking.
So I post something in the chat.
Is it the past paper you posted right there? Is it the past paper down here?
Yeah.
All right, thank you, Sonia. I see it. I am going through it. I am not finding the type that I want. I'm not finding the type that I want, but I still have enough time in class that we could possibly do one of these questions. How many papers you put in the group? Just one?
Yeah, I just hit one.
All right. I will look at the one that you just sent. I'm looking for a type. All right, so yeah, so this one has the one that I'm looking for. This one has the one that I'm looking for. So right, that's it, yeah?
Okay.
Yeah. All right, so I'm trying to copy the question. We're going to end up doing both questions, but I want to see how well you do on this one first. So let me just print screen this one here and extract this question. Nope, that's not it.
What we say? Okay.
Hold on, guys. All right, guys, you're not seeing my screen, right?
No, sir.
No, sir.
All right. All right. Hold on a minute, please. Can someone please send me the link for the class in WhatsApp? I don't know what happened just now. Thanks, Joe. The morning this computer connectivity and everything just getting to me, honestly. Can you see the screen now?
Yes, sir.
That's what I want you to work on. Please.
So I sent you the answer in the chat.
Check it out. All right. Let's check this. Yeah, it look right, you know. I have not worked it. I mean, I work it in my head. That is that. That is that. And that one is that. And that is that. Yeah, it won't right. That one actually equal. 2 times 3 is 6. 2 times 3 is 6. Minus that is 4. Yeah, it seems correct. Anybody else get an answer?
I got one, but I'm still looking it over.
All right, if you over. I don't want to come in yet. I want you guys to do this. If you, once you can do the questions of this type, this nature, you should be fine. And it means that you fully understand the topic. Once you can do the ones with the unknown, it says to me that you would fully understand the topic. And remember, we have one more to do that Daniel found in the past paper. And depending on how it goes, I may move into another topic. We meet once a week. I'm not starting to write until I hear from the rest of you. I recognize that people are dropping without necessarily saying to me that they are going.
This meeting is being recorded.
So there are only 5 of you now. Welcome back, Nikki. No, seriously. Tara, Daniel, Crosswell, where are
Sir.
your answers? You want the answer?
Same here. I'm still working.
Alright. Okay.
Back, what was happening?
So this is Wormwood. I don't like All right, the screen sharing not working again. Let me stop sharing and try sharing again. Okay, now come up. So that's what it is that we're supposed to be doing. All right. I see you put some stuff as well. I'm not sure if I'm following. Remember, you know, it is asked to find the value of A and the value of B. It is asking to find the value of A and the
Oh,
value
oh,
of B.
that's there as well. I just didn't want to send you the entire thing at once.
Okay.
You want me to send the first part of the explanation? Sir, can I hear you?
So A is just what A is. All right. I'm struggling with the technology today. And it's not just your class. From morning, it has been. Are you hearing me?
Yes, sir.
Yeah, I'm just saying I've been struggling from morning with the technology. I don't know what is happening. So
Recording in progress.
all right, let us just do this one question and then we call it an afternoon. It says state the conditions for for a function to be continuous for 3 marks. What are the conditions for the function to be continuous?
Wait, so you're asking us?
Yes,
Wait, you're
sir.
asking what are the terms for function to be continuous? That's why I ask.
Yes, sir.
Well, for both values of the expression to be equal to each other. So like say you had x what's the term now? Function 1 and you had function 2 and it will give you 5. That would be a continuous function. But if you were to receive a function and both value and when you calculate it, you got 5 and -5, then that would be a discontinuous function.
Yeah, whereas you are correct, that is just the last piece of it. You recognize that there are 3 marks? Because there
Yes.
are 3 conditions. What's the first condition? I've said this before, and I'm going to say it again. I'm going to stop sending you my notes, and I'm going to ask you to start writing notes in class. Because I swear that when I send you the notes, you guys don't look at them. When I send you the notes, you guys don't look at them. You don't look at them. You say that you have them, but you don't look at them. You don't look at them. I'm convinced you don't look at the notes when I send them. Can you look at the screen for me, please? Did I send this to you?
Yes, sir. You also did it in class.
So why not answer the question? I asked the question, guys. Let me just say something.
I
No,
thought
hold
I
on,
want somebody else to
Crosswell,
respond.
hold on. Crosswell,
No.
hold on. Because I gave you an opportunity, and you.
I was waiting on somebody else to answer
No,
because I thought
Crosswell. I asked you, and you gave me the condition. The last condition, you gave me condition number 2, part B. You gave me condition B. Let me say this. I'm going to say this. On a Saturday, I have a class from 8 o'clock to noon. And then I have you from 1 to 5. And I'm doing this because I really want to see you guys through with the calculus 1. But you guys are not being responsive to me at all. And when you don't respond to me, it makes my class lethargic. I just feel very lethargic. But what is also important, I will insist on not sending you any more of my typed notes and make you have to go make your own notes, or you listen to me in class and make your notes. Because I can't send you something like this. The document. And especially this, please note, those 5 points that I sent you. And it's not last night I sent you the document either. And you guys still not reading the stuff, and you come to class and I'm struggling to get you guys to understand it. Come on. The only person in class who's supposed to be struggling right about now is Nikki, because she just joined for the first time today. All of you had this from before. not work out. And you need to let me know if you're really committing yourselves to this Saturday afternoon, because I really don't want to be putting myself through this and then nothing comes of it. Can't teach you and understand and really something. Foolishness. So now that you don't have the document, I'm not going to do part A, C handout for part A. And I pray to God that it comes on the exam paper, because you guys are getting my stuff and not reading it. And I'm annoyed about that. You're getting my stuff and you're not reading it. Come on. So C handout for part 1. I'm not writing it again. So it says a function f is defined as follows. F of x is that piecewise function. Yes, please.
Sir, sorry to cut you. Sir, you're sharing the other document that you were sharing previously.
No, I'm sharing that one.
Which document you're talking?
I'm sharing the past paper excerpt 2015. Are you seeing that?
It's
Yes,
just
sir.
seeing it now.
All right, cool. So I'm not doing part B for those 3 marks. Based on what you said to me, Crosswell, you'd have only gotten 1 out of the 3 marks. Let us look at the piecewise function for 8 marks. And then we'll just call it a day after this. Determine the value of A and B such that f is continuous over the interval x is greater than negative infinity but less than or equals to positive infinity. All right. So what I need to do is to look at the limit as x tends to 2 to the left. It's -2 actually. As x tends to -2 to the left. To -2 to the left, that limit is 2x. That implies 2 times -2, which is equals to -4. That implies -4. Need now to look at the limit to the right. The limit to the right of -2 is going to be given by ax minus ax plus b. The limit to the right is going to be ax plus b. Now, in order, it says to determine the value that f of x is continuous. So we need to look for it. We need to make it continuous. So in order to make that continuous, it must be equal to -4. So a times -2 plus b must be equal to -4. It has to be equal to -4 so that both limits are equal. So we're going to have -2a plus b is equal to -4. And this is going to be my equation 1. And of course, I'm going to end up with a simultaneous equation. So that's the first part. The second part of the question now is to say that the limit as x tends to, I think it's +2, is 3x.
Yes, sir. +2.
3x minus 2. Positive, I'm looking at the right first. 3x minus 2. Anywhere in the function I see x, I'm going to put 2. So it's 3 times 2 minus 2. 3 to 6 minus 2 is equals to 4. All right, so to the limit to the right is supposed to be equals to 4. The limit as x tends to +2 to the left is going to be ax plus b, and that must be equals to +4 because these two limits must be equal. So anywhere in the function I see x, I'm going to substitute 2. So I'm going to end up with 2a plus b is equals to 4. And that now becomes my equation 2. That becomes my equation 2.
Sir,
Now I need to go ahead.
sir, what if you only have one equation? It can work still?
I can't solve one equation with 2 unknowns.
Thank you.
So I'm going to have negative 2a plus b equals negative 4. And positive 2a plus b is equals to positive 4. Now, that's my equation 1, that's my equation 2. I'm eliminating the a's, so if I add both equations, I get rid of the a. Negative 2a plus 2a is equals to 0. b plus b is 2b. And negative 4 plus 4 is equals to 0. Implies that b is 0. Put b equals 0 into any of the equations. I'm going to call equation 1. Anywhere in equation 1 I see b, I'm going to put 0. So I'm going to have negative 2a is equals to negative 4. Divide both sides by negative 2. A is going to be equals to 2. So the value of a is going to be equals to 2 and the value of b is equals to 0. And those are your 8 marks.
Sir, I'm not sure if it's me alone, but you're kind of breaking up.
I'm breaking up?
So you were just now.
Okay. Right. So a is equals to z. A is equals to 2 and b is equals to 0. And those are my 2 values. Those are my 2 values. Any question?
Those. Sir, are we
All
going
right.
to do one with fractions? Like
Yeah, you can
intensity.
if you can get 1 with fractions. Yeah. You can get 1 with fractions. You can get 1 with fractions. You can get 1 with fractions, miss. Um I did say, well, that's the end of talking for me for now. I did say that I was gonna give you the question that Daniel had sent. And I'm gonna try and find my question now and give you a couple of minutes. I'm going to hydrate myself somewhat. Allow me to just copy the question for you. All right. Oh Lord, which year was this again? This is August 2016. right. Start working on that one for me, please. That's the final question for the afternoon, and then we'll call it a day. All right. So I'm going to mute, and so just work on that one for me, please. And thanks.
Sir, I sent you the answer in the chat.
All right, I saw those two answers. Daniel, I'm concerned that I've lost you again.
Sir, I have trouble seeing the screen currently.
Okay. Um,
Sir, I'm seeing it now. I don't have the question. No.
you don't have the what?
Question.
Well, if you're seeing the screen, that means the question is being projected.
Seeing a blank screen now.
I think something is wrong with your system. Anybody else see my screen?
I'm seeing it, sir.
Sir, I don't know what's going on, but I'm
Are you
seeing
using
it
your phone?
now. Tablet.
Okay. You see this? It's in the full screen now with the question on it?
Yes.
Mhm. All right. Determine if a function f of x is continuous at the point x equals 0. So the limit as x tends to 0 to the left of 2x squared minus 7x plus 3
It would be 20 minus 70 plus 3. 20 squared minus 70 plus 3.
that's 0 minus 0 plus 3. So the limit there is 3. And the limit to the right of 0 is going to be with 3 minus 4x. Anywhere in the function I see x, I put 0. So it's 3 minus 4 times 0. So therefore, since the limit as x tends to 0 to the left of f of x is equal to the limit
Sir?
All right, I got kicked off a while ago. All agreed?
Yes, sir.
Wait, the screen gone again, sir.
Yeah, I know. I'm trying to get it back up. I got kicked out a while ago. All agreed?
Yes, sir. Yes, the function is continuous at 0.
And then now I need to look at the limit as x tends to 1 to the left. It's going to be 3 minus 4x of 3 minus 4x. It's going to be 3. Ouch. Minus 4 times 1. It's going to be 3 minus 4, which is equal to negative 1. And then also I'm going to look at the limit as x tends to 1 to the right of x squared over 2
minus x
uh-huh.
plus 3 over 2.
All right, so it is going to be 1
over 2
square over 2.
Yeah, 1
minus,
square over 2 minus 1 plus 3 over 2.
Right. So 1 square over 2 is going to be a half minus 1 plus 3 over 2. Look at what I'm going to do. I'm going to rewrite this as a half minus 2 over 2. Is 2 over 2 the same thing as 1?
Yes.
Right.
Yes.
So, right. So I'm just writing this.
So now they all share the same
LCM denominator.
Yes, denominator.
Yeah, and that's why I did it. Why I did. So those two are the same. So now I can find the LCM here is to be 2.
Just the addition, sir. All of it I got just them are just multiplied by 1.
So I get 1. Anybody got 1?
Sir, isn't it 1 over 2 squared?
No, where get the square from?
It's 1 squared over 2.
It's 1 squared over 2.
Okay.
So are those the same?
Yeah.
Yes.
No, one is negative and one is positive.
Oh, why am I keeping on forget that? Me even write it down.
So since the limit as x tends to 1 to the left of f of x is not equal to the limit as x tends to 1 to the right of f of x, comma, then f of x is discontinuous at x equal 1. Discontinuous at x equals 1. All right, and I would have just sent you the notes for the day, what I would have used in class today. And there you go. We can peruse it, look through again to see if there's any error on it. We can discuss those next class.
Sir?
Yes,
Sir, it's operating where you are right now, sir?
Say it again.
It's operating.
It's what?
Rain.
Oh, rain. It was. It was like moments ago. It stopped now.
Come off some clothes in the machine we want to take out. But
Yeah, man, go and take them out, man. Little son.
Sir.
Man. Yes, please.
Question, the recordings for the previous class, are you able to send it in the group?
All right. So
I can watch and go and
come on.
what
Give me a few when this is done. I don't think I sent off last week's. So give me a few when this one comes up. I just send out I send them out for the later. If you don't see it, you can just send a message in the group to remind me.
Okay, sir.
All right, bless up. Have a good one, guys.
You too, sir.
Same to you, sir.
Yeah, man.